Hey, good morning everyone and welcome to your channel Learn Data Science with Pranjal. So in this knowledge video we will discuss a topic that is power of testing, and this knowledge video is basically the continuation of my previous video that was your hypothesis testing. In this knowledge video we will try to understand how to increase the power of testing or basically how effective your testing is. This knowledge video would basically be a theoretical video, but it will give you a very good and clear understanding of the factors which you need to keep in mind, or which the factors which probably you can control so that you can increase the effectiveness of your testing. So let's get started. Power of testing basically depends upon three factors, that is your sample size, randomness and confidence interval. So basically if your sample size is more, your power of testing or your effectiveness of testing would also be more. Randomness. So as the name suggests, the randomness, if your randomness is more, probably your power of testing or the confidence you will get on your testing would be less. And then you have your confidence interval. And the third one is your confidence interval, the amount of error probably you are taking or assuming while you are trying to do your testing. So let's try to discuss each factor one by one. So now let's discuss sample size. So I have created a few scenarios based upon the sample size, and I have pasted it over here, but you can understand these numbers only when if you have seen my previous video, or probably if you have not seen my previous video, then let me quickly discuss the scenario on which these calculations are based. So in my previous video I have taken this example. So a company wants to launch a new toothpaste with salt and mint flavor. It did a random sampling on some 200 customers and finds that acceptance rate among them is 33%. Assuming 90% confidence level, help the company manager whether to launch the product or not. Acceptance rate of the current toothpaste is 30%. So in this example, basically your 200 is your sample size. Survey was done on your 200 customers. 33% is the number which you are getting from the sample. This 30% is on your population because you are on the current toothpaste, and there would be thousands and thousands of packets of toothpaste already in the market. This 1.645 is your given value. So remember that if your calculated value falls in the critical region, you reject the null, otherwise you don't reject the null. So this is an example of right tail test. Why? Because we will launch the product only if the acceptance rate is more than a certain thing. Now let's try to change the sample size. And so if I take the sample size as 200, sample mean as your 0.33, which we have discussed, population mean as your 0.3, confidence interval your 90, given value is 1.645. So this is your calculated value. You can see my previous video of how the calculation was done. So basically p minus p upon the square root, p into 1 minus p root n. So what do we see that when 200 people, or when we have done a survey on 200 people, and out of 200 people 33% say that you should launch the product, but still we are not able to launch the product because our calculated value is 0.92, which is falls in your region of acceptance. So we fail to reject the null, and that is why we do not launch the product. So even when, so product can be launched above 30%, but 200 people are saying 33%, but still we are not able to launch the product. So slowly from 200, if you see that I'm slowly increasing the values, I'm increasing the values from 300, 400, 500, 600, and at 650 I get the calculated value as 1.669045, which is more than 1.645. Since the calculated value is more than the given value and it's a right tail test, so the calculated value falls in the critical region, and therefore we reject the null. And since we reject the null, we will go ahead and launch the product. So from this example, basically what we can understand is that if out of 200 customers, if 33% are saying, okay, your product is good, we are still not sure whether my product is good or not. But if same 33% people say, if I get the same 33% on the larger sample, that is on my 650 records, then I am quite sure, okay, that my product is a good product. So basically, if you increase the sample size, your power of testing or your effectiveness of testing will increase. Let's take another example where we'll discuss the randomness. What is the effect of randomness on the power of testing or on your effectiveness of the testing? So over here I've created a scenario, but to understand this scenario we need to refer to a second problem statement which we have discussed in a previous video. If you have not watched my previous video, let me quickly discuss the problem statement once more. So this is the problem statement. A company making snacks writes that maximum amount of trans fat per packet is 2 grams. Test of sample on 45 packets shows that average trans fat is 2.1 gram. Assume that population standard deviation is 0.25 and Z critical is 1.645 at zero point 0.1 significance. 0.1 significance implies 90% of an error. Should the food regulator impose the fine on the company? So over here, this 2 gram is your population mean because it is written on each and every packet and there are millions and millions of packets probably of that company. Test of sample on 45, so sample size is your 45. Average trans fat is 2.1. This 2.1 is on your sample. Assume that population standard deviation is 0.25. So this is my standard deviation. 1.645 is my given value, and then I'll do the calculation and see and find my calculated value, where my calculated value is. So this is again my right tail test. If my calculated value is more than the given value, I will reject the null. So now let's see our calculation for different values of the standard deviation. So same thing I have recreated over here. So the first record. So in this example, basically I am discussing the randomness. So you can see that for all the columns, you will see the values are same. Only change you can see in your STD, that is your standard deviation. So you can see the changes in your third column from the right hand side, STD standard deviation. So at your 0.25 standard deviation, the calculated value is 2.68. So we are, which is more than your 1.645. So we reject the null. And as we keep on increasing the standard deviation, you will see that the calculated value keeps on decreasing. And at 0.5, probably we are rejecting we fail to reject the null. So it means if your confidence, so what is the last example shows? Last example shows that when the randomness is more, your confidence or your power of testing has gone down. So even when the trans fat was much more on the sample, even when the trans fat was much more on the sample what it was quoted on the packets, but you are still not able to impose the fine. Why? Because your standard deviation, or in a way you can say that your randomness is very high. Let's discuss the third factor, that is your confidence interval. So in confidence interval, I have again taken a similar example. Only thing is, instead of changing the other values, what I am doing is I am changing the confidence interval. I am changing it from 90 to 95. So if I change the confidence interval, your given value will change because at each confidence interval, your given value is fixed. So from 1.645, it changes to 1.9645. So you can see that calculated value is still same, but now the comparison has changed. Previously you had to compare with 1.645, now you need to compare with 1.9645. So when you are comparing with 1.645, you are rejecting the null. But when you are comparing with 1.9645, you fail to reject the null, or basically you are accepting the. So in this example, what does this increasing the confidence interval imply? So when I'm increasing the confidence interval, I want more surety. So even when the trans fat was more on the sample, which was mentioned on the packets, still I am not able to impose the fine. Why? Because the calculated value is less than your given value 1.9645. So it still falls in your region of acceptance. So I want more surety before I can imply the or impose the fine. So basically remember two things, that if your sample size increases, your power of testing or the effectiveness of testing will increase, and this should be the main factor which a person should consider while doing the testing. And then comes your standard deviation. Standard deviation is probably not a main factor. Why? Because it is sometimes beyond the control of a person. You cannot control probably the standard deviation of the data. It is the nature of the data, so it will probably exist. And the power of testing, the third parameter is your confidence interval. Probably this can also not be controlled much. Why? Because various industries and various verticals and business units already have their cutoff decided based upon the previous experience and their requirements, that what confidence interval do they want. So basically we should be focused on increasing the sample size. You increase the sample size, your power of testing or the effectiveness of testing will probably increase. If possible, try to decrease your randomness so that your effectiveness increases. So before ending this knowledge video, let's quickly discuss what is type 1 and type 2 error. These terms are oftenly used. Okay, what is type 1, what is type 2? Let me quickly discuss what is type 1 and type 2 error. So type 1 error is an error when we reject the null, when the null hypothesis is valid. And type 2 error, also known as beta, is an error when we fail to reject the null when the null hypothesis should have been rejected. So normally in the industry, people are likely to make the type 1 error. So when you make the type 1 error, basically you reject the null. And when you reject the null, you do something different, you do something else. And that is what the tendency or their human mentality is. They want to do something else. So they are very likely to reject the null when the null was valid. And if you have gone through the previous example, probably you would have noted that when you reject the null, you do something else. You do something new. And in business scenarios, probably you will do something new. You will launch a product when you should have not launched it. So probably if you are launching a product when you should have not launched it, then you are making a very costly mistake, because after launching of a product, maybe after several months or few months, probably you will come to know, okay, your product launch was a failure. You should not have launched it, but probably you launched it. So which involves a huge amount of cost, and you also lose the customer experience also. So type 1 error is a very costly mistake to make. Now let's come to the type 2 error. It's an error when we fail to reject the null when null hypothesis should have been rejected. So basically in this scenario, probably you can think, okay, a product should have been launched, but you did not launch the product. In business scenario, probably you can say, okay, you were not able to gauge the sentiments of your customers. Customers wanted that you launch something new, but probably you're not launching. Okay, fair enough. Doesn't sound very costly mistake upfront. So if you make this mistake once or twice, probably it's an okay. But if you keep on making this mistake, probably your competitors will go ahead and you would be phased out of the market. So one of the classical examples could be a phone manufacturer like your Nokia. It was a market leader somewhere from till 2007 and 8, but probably they could not gauge up the coming sentiment of the coming inflow of the or the requirement of your smartphones. They could not keep it up pace, so probably they were making the type 2 errors. They were not launching the product which they should have launched. So it type 2 error doesn't seem that costly mistake, but probably it can slowly remove you from the market. So both the errors are in a way costly, but upfront type 1 error is most likely to be committed. This brings us to the end of this knowledge video, and I hope you enjoyed this knowledge video. Basically, this knowledge video was continuation to the previous knowledge video, hypothesis testing. So I'll suggest please watch the previous video, and then you will get a much more clarity on this video. So if you have liked the video, please go ahead and click on the like button. Thank you everyone for watching the video. Hope to see you soon in my next video. Till that time, happy learning.